Hello and welcome to Innovation Celebration, the show where we celebrate recent advancements in science and technology, the people and ideas who make them possible, and the ways in which they advance human flourishing. I'm Angelica Worth.
And I'm Thomas Walker, and I want to start with one of my favorite things that happens in the field of innovation, which is when technologies from Star Trek become real things. And it's happened many times before with tablet computers and mobile phones and things like that. And now it might be happening with what's called tactile holograms. And hologram is sort of projection of light in 3D space. But it becomes, that's kind of existed for a while. Like it doesn't exist in the full sort of Star Trek sense, but on screens and within mirrors and things, holography has been a thing for a little while now. But tactile holograms are holograms that you can actually touch and interact with. On Star Trek and other shows, they have force fields or whatever that make it possible to physically interact with holograms, but there's a couple different projects trying to make that happen for real. And the one that has a recent breakthrough is the Bendable Electronics and Sensing Technologies Group, or the BEST group, at the University of Glasgow in Scotland, led by Professor Ravinder Dahiya. I think I'm saying his name right. I couldn't find any examples of his name being spoken out loud online, so I'm just guessing at that one. But his project, basically, they created a holographic basketball. And so the actual visual aspect of it, they used a very old technique called Pepper's Ghost, which is named after John Henry Pepper, a mid-19th century English illusionist. And what he would do is, when he was on stage, he would do these pieces where he interacted with a ghost that could pass through things. And so what he had this glass that just covered the entire front of the stage. So the audience, unbeknownst to them, were watching him through a window, effectively. And then sort of down in the sort of part of the theatre where the orchestra would normally be, in front of the audience, out of view, is another performer playing the ghost. And a giant mirror is angled so that that performer's image actually appears up on the glass. So there's this kind of translucent holographic, in the 19th century context, character who he can interact with. And this is still used to this day in theatre performances and theme parks.
Yeah, if you've ever been to Universal Studios in Orlando at their Gringotts, I think it's Great Escape is the full name. But they, near the beginning, they have, I think it's Bill Weasley and one of the other characters who are interacting as though, and it looks like a hologram, but they're actually using an updated version of Pepper's Ghost to make it look like this isn't just a screen, this is 3D people that are walking around and talking to you.
Yeah, and it's used at Disney World in California. It's used in all sorts of theme parks, haunted houses, things like that, all over the world as well. And so those examples and this example are obviously a lot more advanced than just somebody's actually standing there off shot. This is using modern video technology to make a more convincing image, and they're using a similar volumetric display, they call it, to create this 3D image of the basketball. The difference here is that they've set up a system where there's precisely timed and controlled jets of air, so that when you reach your hand into the space where the non-existent basketball should be, you encounter this resistance. And it creates a feeling of touch. And they've set it up using computer control so that the more you press, the stronger the resistance is. So it's not just, you get in there, it's like, there was another Florida ride that I went on, Honey, I Shrunk the Audience, where they use jets of air by your feet to make you think there are rats running past your feet. It's more complicated than that. It's actually reacting to the level of pressure that you're pressing down. So the ball is compressing, and the images. So modern computer technology makes it possible to time all of that together. So it's it sounds like a sort of fun gimmick, but they actually see it as having some quite serious applications. And I'll just read out a quote from Professor Dahiya, I think. He says, we believe aerohaptics, and aerohaptics is what he calls this. Haptics means the sensation of touch, so it's using air to create that sensation of touch. He says, we believe aerohaptics could form the basis for many new applications in the future, such as creating convincing interactive 3D renderings of real people for teleconferences. So imagine, those blue holograms in Star Wars where somebody's head appears on the table and has a conversation with someone. He goes on to say it could help teach surgeons to perform tricky procedures in virtual spaces during their training, or even allow them to command robots to do the surgeries for real. So, and on that latter point, if you remember my Boston Dynamics robot piece a few weeks ago, I was talking about how having a robot go into a dangerous situation like a disaster site or a inhospitable environment, might get a human out of that situation. Well, if a human is back at base in a holographic environment, controlling what the robot's doing in real life, you could have a situation where that human being can do everything they could do if they're a rescue person trying to get somebody out of a disaster or something. The robot can do it for them, lift all the massive lumps of concrete that a human couldn't lift and things like that, and have all of the tactile sensations and everything to be able to do that properly. So that's quite an exciting development. And for the surgery example, obviously you'd need a lot more finesse and detail in the simulation than a sphere. And that might seem like a leap at the moment. How can you get that with just squirting jets of air? But I was thinking when I was reading about this, the sort of allegory occurred to me that I've often found it amazing that speakers play sound just by beating a drum. And at some point, the early speakers couldn't produce much in the way of fidelity doing that. But now we have that ability. It just gets more and more finessed, and your little headphone speaker with its little drum banging backwards and forwards can just recreate complex sound and basically any sound, and to varying degrees. And I think this is going to go down the same process. Maybe not this specific technology, but technology like it is going to go down that same process. You'll just go from simple shapes to more complex, and they'll find ways to increase its fidelity and its ability to convey different sensations. So I also wanted to briefly compare this to two other projects which are in the same space, just to give a sense of how this whole concept.
Before we move on to that, could we just talk about other potential applications of it? When you were first sharing this information with me, it seemed like this could be great for physical therapy if it can be more precisely adjusted to a patient than what a person could do. And he mentioned a little bit, training for surgeons, but really this could be used for training for all types of people, for our military, for anybody who's got a precise job to do that you kind of don't want them doing for real at first.
Yeah, exactly. It kind of becomes a flight simulator for all sorts of different,
that's a good comparison.
Different professions, and then also, it's not just sort of disaster recovery, but the controlling a proxy thing would be useful for exploration as well, and volcanism and exploring on other planets and things like that. Environments where being able to actually interact with the soil, without needing to be in a spacesuit or something might be. There's all sorts of really exciting applications to it, as well as just the obvious like entertainment value. There's the kind of 3D computer games direction of it as well. Or bring up the Star Trek example, they use the holodeck to recreate crime scenes or to try and figure out what happened in a situation. They rebuild things, we know that there's a shadow here in this photograph, so let's try and imagine what shape created that, and using it in those sorts of ways. So there's all sorts of interesting applications to this if it gets somewhere serious. But as I say, there's a couple of other projects at different universities progressing different means of doing the same thing. At the University of Sussex, a team led by Ryuji Hirayama is pursuing an option with small particles that are suspended in the air with ultrasound and lit with they're colored particles, and light is fired at them. So they're too small to see until the light is being thrown at them, and then they rebound that light. So they between create an image that then has a tactile element because it's physically there. It's these little particles. And then there's one at the University of Tokyo called Mid-Air Haptics, using ultrasound to push against the hand rather than air. So again, it creates that. Their thinking is this is for sort of headset VR, and instead of having a glove that's feeding sensations to you in that kind of Ready Player One style, it's more that you have that more physical interaction without having a glove on your hands. So these are all quite exciting opportunities for developing this more. I've already talked about the applications there, haven't I? So I think that's pretty much all I had to say on that. But it's something that got me excited because holodecks are something I've dreamed of having for real life ever since sort of 8-year-old me first turned the next generation on.
Yeah. Awesome. So the thing I wanted to feature on our show today is basically a genetic mutation found in bacteria that could be used to fight aging, to extend lifespans. So I'll break that down into its different parts, but I don't want to lose sight of the fact that it's very exciting because it could potentially be helping people to live longer and to live healthier in their old, to be healthier in their old age, and thus to flourish more fully and for longer.
Yes, as a theme we've brought up a couple of times, isn't it?
It is.
Extending aging and improving life quality go hand in hand.
Oh, absolutely. Yeah, totally. It's no good to live longer if you're going to be in a hospital bed the whole time. But if you do get to live longer, that means you have better, more time to flourish. So, anyway, this specific mutation that I'm talking about was first found in extremophile bacteria that live in very high heat environments. So maybe if you remember from your biology days in school, there's this funky class of bacteria that can live in really strange situations, including really high heat. And so they found this mutation that basically helps make better proteins. And I'll explain a little bit more how they do that in a minute. But let me first explain the results. So when they took this mutation and they inserted it into fruit flies, yeast, and worms, and they inserted it using a technology we've talked about before, the CRISPR gene editing technology, whereby they snip a little bit of genetic material and insert it into another organism. Same thing.
Sorry, a little piece of news about CRISPR I saw today, by the way, is that it's one of the European Union restrictions that the British government is planning to lift is on gene editing.
Oh, fantastic. Yeah.
That's just been announced, so that's really positive, I think.
Yeah,
and
the
CRISPR
European
was specifically
Union
mentioned in that article.
Yeah, the European Union doesn't approve of gene editing, so that's one of the advantages of the UK no longer being in it. But yeah, so when they inserted this mutation into these small organisms, they found that they were able to live much longer by a factor of about 9 to 23%. So to put that in human terms, adults in the US have an expected lifespan of 75.84 years. If we increase that by 9%, that's an extra 7 years.
You'll catch up to Europe at that rate.
Yeah. Obviously, individual circumstances vary, but but the other thing that's notable, like Tom was saying about, you want to be healthier at the end of your life. These insects did seem to be healthier at the end of their lives. The fruit flies were moving more easily. The worms were reproducing more. And then all of the organisms in this were also able to withstand higher temperatures, which makes sense if the mutation came from thermophilic bacteria.
Yeah, so I mean, you've just mentioned the word thermophilic, and I've heard of these referred to as extremophiles before.
Yeah, it's a type of extremophile.
Yeah, because a lot of sort of recent thinking about life on Mars and Jovian moons and things like that comes from the fact that we're increasingly finding that small microbial life forms can exist in horrible environments, like high acidity environments. I mean, some bacteria survived on the moon for 3 years with no air and 500-degree swing in temperature. Yeah. So it's astonishing, the environments that some of these things actually thrive in.
Yeah, and so this mutation, we think, is possibly because of that environment. So I'll explain how. Basically, like I said, it has to do with the making of proteins. So let's go back to basic biology really quick to remember how proteins are made, because it's relevant. So your genetic material, your DNA, your RNA, depending on what kind of organism you are, codes for the making of specific amino acids. And what is making those amino acids are little organelles, which is, the analogy is, your organs are a part of your body that perform a specific function. You have the same thing in your cells. Little things that perform specific functions.
My cells have a little heart and a little lung and a little...
They have different names and different shapes, but in your cells, you have what are called ribosomes, and they make amino acids from your genetic material. And once these amino acids are made, like as they're made, they form little chains, and then those chains have to be folded up. But this sounds like a pretty complex process, right? And whenever you've got a complex process, you've got the capacity for error. Yeah. And anti-aging researchers have noticed for a long time that we have a high concentration of errors in older people, particularly in Alzheimer's patients and in Parkinson's patients.
So it's almost like, so it's like how computer code corrupts over time. Like the more you copy and paste a file, the more it corrupts.
Well, not quite. So in this case, they're thinking, well, there are a couple of different causes. So the errors that we can be finding, part of it is just all of our cells are making these mistakes all the time. But when you're younger, your cell gets rid of the bad proteins, the proteins that are stuck together or the proteins that aren't folded right, your cell will get rid of them. But as you get older, your cells aren't as good at doing that anymore. So that's one thing. And they've known that for a while. But the new thing is finding that just the ribosomes aren't good at it anymore. And so this mutation reduces the number of errors in the first place. So it's less for your cells to keep up with, basically. And the reason that it's kind of not surprising that you find them in the thermophilic bacteria is because these errors are more common when it's hot. So it makes sense that these creatures developed this mutation to deal with this side effect of the extra heat, basically. And yeah, like I said, so it's kind of a paradigm shift because we've known for a long time that these errors were happening, and we were kind of focusing on, well, how do you deal with them? But this is going back more to the cause. A lot of these errors are happening with the ribosomes, sorry. So ribosomes are plant parts in the ribosomes. So if we can fix the ribosomes, we're fixing the problem at its cause. A quick word about who's been doing this. The research is led by Ivana Bielov at University College London. One of the co-authors on the study is Felipe Cabrero of Medical Research Council's London Institute of Medical Sciences. And where we're going next, the fruit flies, yeast, and worms are all pretty simple creatures. We are not simple creatures, so we need to be testing this on some more complex animals, potentially mammals.
Fruit flies are the go-to experimental creature.
Well, just because they breed very quickly, so for genetic research, it makes sense to use them as a starting point. But more immediately, pharmaceutical companies can take this information and can say, okay, we need to be focusing on the ribosomes. We need to be triggering the same effect that this mutation is triggering. How can we do that? So it's already, a step up for them. And then Cabrero says his next area of research personally is, well, we found this one mutation that does this cool thing that helps us prevent aging. What if there are more? What if other animals that live in, or creatures that live in extreme environments have some kind of mutation that we could use? And so he's going to be exploring that. So very exciting for, as I said at the beginning, living longer, healthier lives so that we can flourish for even longer.
Yes, definitely.
So I'm going to move on to our honorable mentions then.
Yes, although I think we both kind of found honorables that we want to give a bit of time to as well, so it might be a bit more of a kind of half feature. But so as we're recording right now, it will have returned by the time people watch this. But right now, the Inspiration 4 mission is in orbit. And this is the first time that a fully civilian crewed orbital spaceflight has occurred. So I've talked a few times about various suborbital private spaceflights that have happened recently. Right after we started, we had the Virgin Galactic launch, and then the Blue Origin launch shortly after, the Richard Branson and Jeff Bezos space flights. The problem is, so there's a couple different definitions of where space begins. The entire world, except for the United States, uses what's called the Kármán line, which is 100 kilometers or 62 miles up. For some reason, America uses a lower 50-mile cutoff, it's about 80 kilometers. To be fair, when you're at that altitude, it's black. There's hardly any air. Like, it's basically space. But there's two different definitions of where space begins. There's also other ways of thinking about it, because higher up than that, there's still air, even at the height. Like sort of 200-300 miles up where the International Space Station orbits, there's still a little bit of air at that altitude. It's enough to exert a drag effect on spacecraft at that altitude. Even higher than that, at the Van Allen belts, the magnetic field, so that's still within sort of Earth's sphere of sort of control, if you think of it in those terms, and the gravitational field goes further than that. But yeah, if we treat that 100-kilometer, 62-mile line as the Kármán line as the edge of space, Branson didn't quite reach that. Bezos just about reached it.
This is the line that the other countries use, not the US?
Yeah, this is the internationally recognized line. Branson got over the 50-mile, and Bezos just about got to the 62. But neither of those were orbital space flights. They were suborbital. So they were just, you go up, you kind of fall around for a moment, and you fall back down again. And so they just had a few minutes of weightlessness at that kind of what we call an apogee, the top point of the curve, and then fell back down again. And so, it's enough to give people a bit of a sensation of space and a view of the Earth and everything. But as I say, the ISS is 3-4 times higher than that. And to get into orbit, i.e. to go all the way around the planet, you have to get up to enough speed that you're effectively, so if you think of the ground being like this and you fire something, it falls like that. What orbit is you fire something that falls so fast that the curvature is the same as the curvature of the Earth, and it falls all the way back to where it started from. And that's what an orbit actually is. You're just falling eternally around the planet. And so way more energy required to get into orbit than to do those little suborbital flights. And SpaceX, Elon Musk's company, developed the Falcon 9 rocket, which is able to launch into orbit. And most of their flights so far, they had the cargo version originally, so that had a lot of commercial clients, but all of their passenger flights since they launched the Crew Dragon last year for the first time have been NASA contracts, flying people to and from the ISS. And the Crew Dragon is really largely built on those government contracts. This flight is interesting because this is the first time that they've launched one entirely funded and paid for by civilians and entirely crewed by civilians. So this is by far the furthest, this is the first truly private mission into space.
It's worth noting that 2 of these passengers are pilots, though. They're not sending complete rookies up there.
No, it's not like they're just like, you go to space, figure it out as you go.
That was the first thing I thought when I heard civilian spaceflight. I'm like, but who's going to fly it?
No, so the man who's responsible for this happening is Jared Isaacman. And he's a billionaire. He was the founder and is the CEO of Shift4 Payments, which is a payment handling company. And so he made lots of money, a bit like how Elon Musk did by creating PayPal. He's made lots of money by making payments easier for people and cheaper for people. And he's now putting that to use in trying to push spaceflight forward. So he funded this mission. He's also a pilot in a commercial sense, in a private sense, so airplane pilot. So he's actually commanding the mission. And then there's 3 other people on the flight. One of whom is a retired US Air Force pilot, so he's the actual pilot on the mission. And then the other 2, one is a geologist, and that's the other thing with orbital spaceflight is it's much more useful for scientific purposes than a suborbital flight. A couple minutes of, or a minute or 2 of 0G, you can achieve that on the what they call the Vomit Comet, which is the plane that does dives to simulate zero gravity. And yes, or just in centrifuges, all sorts of situations. So you get much more useful microgravity exposure and Earth observation and that kind of thing on an orbital flight. And then the 4th seat is taken by Haley Arsenault, and she's actually a cancer survivor, and she's from the St. Jude's Children's Hospital, which is a charity that provides cancer care predominantly and other care to children struggling.
And they do research as well.
Yeah. And Isaacman had a particular interest in supporting cancer care as well as spaceflight, so he kind of married the 2. And this mission is a fundraiser for St. Jude's, and he wanted to give one of the seats on the flights to somebody from the hospital. So for her, you beat cancer and then go to space as a reward. Just shows you the kind of value that people get if they're able to overcome diseases like that and keep on living if they make the most of it. And I think it's a wonderful story from her.
Absolutely.
This is a big step towards. Well, I don't want to put down the suborbital flights because I would do one as soon as I can afford one, but real space tourism, like what some companies are trying to develop, like there's a company called Bigelow Aerospace who are trying to develop orbital hotels, space stations that you can visit on a flight, and this is the kind of space flight that needs to develop for that to be possible.
Mm-hmm.
And
this is a multiple day trip, isn't it?
This is a 3-day trip, so I think we're on day 2 right now. and or possibly into day 3 by this point. It's a bit different when you're in orbit. You know, you're not really in any one time zone, and the sun is rising every 40 minutes or so. So it's just kind of a different situation. But I was also going to say this mission is higher than any American mission has gone since 2009.
Cool.
Because pretty much every American space flight up to the end of the space shuttle program in 2011, for the last 20 years or so before that, was to the International Space Station. And except for the one mission in 2009 that was to repair the Hubble Space Telescope. And since then, nobody's been higher than the orbit of the ISS until this flight from an American mission. The Chinese have done other things. But there's it's kind of a push back out into deeper space than has been the case. And if you look at the pictures from the flight, the Earth is sort of more of a ball than you normally see it from that lower altitude. So that's quite cool. And SpaceX has a plan to do a circumlunar flight, i.e. where you go out around the moon and back again. Now that is a hell of a lot further than what we're talking about here, but that's what they're trying to build up towards, and that kind of I think this is a real demonstration of the fact that private space flight is entirely possible financially as well as practically, and that's what really excites me about it. It's that step. I think SpaceX taking a tentative step of past being reliant on government for this stuff and actually engaging in real private space operations. I hope they do more of that in the future because it's such an exciting area.
Yeah, absolutely. Cool. So the next project I wanted to give a shout out to is the Orca carbon dioxide remover that just opened in Iceland on September 8th. So
it's got nothing to do with whales.
It does not. I was just going to say that. I hear orca and I think whale. Beautiful creatures, orca whales, but that is not what we're talking about here. Orca is apparently the Icelandic word for energy, and so that's why they've named it that. But basically, this is a collaboration between two private companies: the Swiss company Climeworks, they're a startup, and then the Icelandic company CarbonFix, who store carbon.
CarbFix, I'm reading that there.
CarbFix, is that not what I said?
You said CarbonFix.
Oh, well, CarbFix, which stores carbon. And so these two companies have gone in together to create this facility, this is not a new concept, but this is the largest of its kind and the only one that's functional on an industrial scale, to actually do something that makes a difference. So the scale of this project is that they can remove from the atmosphere and store 4,000 tons of carbon dioxide a year, which is, for scale, about the same amount of carbon dioxide that 870 cars emit per year, roughly. Obviously, this varies depending on how much you drive your car, what kind of car you have, but just on average. And so basically how it works, they have these 8 giant structures that look like shipping containers, but bigger. The shipping containers aren't that big. But they have all these filters and fans to pull in air and remove the carbon dioxide from the other parts, like the oxygen and nitrogen. And then they mix the carbon dioxide with water and they inject it into wells in the earth. And there it will crystallize and, or I think mineralize is the proper term, into this sort of mineral that it can stay in basically forever if nobody disturbs it. And so if you're...
Yeah, so carbon dioxide is a normal part of the atmosphere.
Oh yeah.
It's been a part of the atmosphere.
Mm-hmm. And so, well, actually, that's a great segue to what I was going to say. So the carbon cycle is a natural thing that happens, that certain things emit carbon or release carbon, and other things hold on to it, like trees take carbon out of the air and store it in their bodies, and then it gets released later on.
And we emit it.
Yes.
As we live and breathe, as does every animal, really.
Precisely, yeah. And humans have created additional sources, and a lot of people are very focused on the sources that we've created. But this is an example of us also creating a sink. This whole idea of pulling in carbon and storing it is essentially a sink. Is taking it out of the atmosphere. Something else that's interesting about this project is that it's powered by geothermal energy, which is basically tapping into the energy from the Earth's core using the heat. And that's a form of energy that is renewable in the fullest sense of it doesn't run out as long as you replace the fluid that is involved. But obviously there are some disadvantages to it. This is why we're not using it everywhere. Number one, you can't get to it everywhere. That's why Iceland is a good place for this kind of thing, because how would you say it? There are volcanoes and things that make it easier to get to.
Yeah, it's on the Mid-Atlantic Ridge, so it's right in the middle of a spreading center where there's a lot of geologic activity coming up. The magma is close to the ground, I think might be an easier way of saying it.
Yeah. The magma is close to the ground, exactly. So they're able to tap into it there in Iceland, but it's very expensive, even there. So on the topic of cost, I was curious as to how this project is economically viable, because you're not creating a specific product, so to speak, with this contraption. And so they already have a $10 million contract from a Swiss insurance company to pull a certain number of tons of carbon out of the air over the next 10 years to offset the insurance company's own carbon emissions.
But what's the company's motivation for wanting to do that?
That's the question, isn't it? And that's, the environmentalist debate, I think, has been oversimplified to people who think that we need to go to net zero carbon emissions tomorrow and need to never use fossil fuels ever again. And, there's that side of it, and that humans are a plague. And then the very anti-human extremist side on that side. And then there's the side that, very few people, I think, that are legitimate deniers of climate change, and who don't really want to accept that humans kind of have an effect on the environment, or that effect could have any negative consequences. And there's a lot in between. But the important part is that, whatever legitimate concerns you have about the environment, that doesn't supersede the importance of human life. And so projects like this are so great because they are helping the environment without getting in the way of people living and doing what they need to do well. Now, as I said, that's not how the majority of people think about this. And so you have government regulations, you have people who are calling for more government regulations. We've talked on this show before, you've mentioned in the transport industry, in the aviation industry. Aviation, that's the word I want. And those sorts of things do affect human flourishing, because transport is an enormous value to people. But a lot of that government regulation, it should be mentioned, is driven by public pressure. And again, I think there's some legitimacy to certain concerns, but you don't want to let that become anti-human and anti-life.
Yeah, I mean, there's a question of how much is the pressure driving the policy and how much is the policy driving.
It's sort of a cycle sometimes, isn't it?
But if people are really concerned because there's real science coming out, and and I think that's what a lot of people are, is they see the research that comes out and they think, I don't want to contribute too much to that. And then you have, say, two airlines, for instance, one of them's like, we've partnered with this company that reduces our carbon emissions, the other one doesn't. That might be enough.
Who are you going to pick?
So that might be enough incentive for businesses to want to do this kind of thing. So there's a model where this might work, and it'd be interesting to see to what extent it does.
Certainly. And just a quick note for our viewers who are interested in digging into the science of, environmental alarmism versus what the actual science is and where that kind of reasonable level of concern is. I highly recommend Apocalypse Never by Michael Schellenberger. He digs into the science of what is actually going on there.
Yeah, it's just the state of debate, not just on climate, but generally on all sorts of issues. We had this with coronavirus as well, where just the middle ground is almost not an acceptable place to be for most people. It's either you're just vehemently one side or you're vehemently the other. You're either just, lock everyone down or let the virus spread randomly. And there's no you can't have a nuanced view of, I think this is a concern, but I also don't think we should restrict liberties, which is basically the same, my view on climate as well is, we should take the concern seriously, but also respect rights and have our values straight when we're doing it.
Yeah, and centrism for its own sake is not valuable, but that's a separate thing to having a nuanced view that takes in the appropriate amount of complexity.
Yeah.
And just one final word on the government involvement in this project. They, to my knowledge, have not put in any money into this. These two companies that I mentioned are privately owned, but they have, the Swiss and Icelandic government have committed to supporting and overseeing the project. So I hope that does not turn into interfering with the project, but so far I can't see that it has. So
if they put money into it, then they will be interfering with it, because
the thing is, that's how government money works.
Yeah.
But
it comes with strings attached, so to speak. But the
thing not so to speak.
The thing with government is you get strings whether you get funding or not. Uh, uh,
But anyway, that doesn't take away from the ingenuity involved in the project and the really cool part about it, which is that it helps the environment without hurting human flourishing. So,
no, I think it's exactly the kind of thing I want to encourage more of.
100%. And our colleague has an article coming about that soon. If he's got it up by the time this episode is out.
Oh yeah, John's doing an article.
We'll share that.
John Hersey from Philosophy for Flourishing is doing an article about another similar sort of proactive solution to climate change that doesn't involve restricting rights or human quality of life.
Mm-hmm.
So speaking of improving human quality of life, I want to talk about a little medical thing now, which is it's an interesting intersection between the medical world and the computer science world, because this is a new algorithm that's designed to help probes, I'll talk about probes in just a moment, detect trace elements of bacterial and viral pathogens. So these are the kinds of probes that doctors will put into your body to explore what's going on inside you. And this is something that's being developed at McMaster University in Ontario in Canada. I'm saying that right, Ontario. I've had a tendency to say that wrong. You say Ontario, and I know that's not right. But no, so the algorithm enables the probe to isolate and identify the DNA, the unique DNA of these pathogens. Otherwise, if you take a sample of, like we've all had COVID tests recently, like you take a sample of saliva or whatever, and you're trying to extract or identify something that's in there. It's a really difficult process, as we've seen with the cost and time of these tests sometimes, to get that out and confirm what's there and confirm that there's something there and what it is. And so if somebody has some kind of infection and you're trying to identify what infection that is, you have to get that sample out and then separate the genetic material of the thing you're looking for out from all the other stuff that's floating around in somebody's blood or saliva or whatever you've taken. And so this algorithm has been designed specifically to enable the probe to do that far more quickly. So it sort of automatizes that process. And they've tested it on not just COVID-19, they tested it on the entire family of coronaviruses. And I think we've had an unfortunate tendency since the pandemic to refer to COVID-19 as coronavirus. And coronaviruses are an entire, as I say, a whole family that includes many kinds of common cold, flus, the other SARS from 6-7 years ago, and the various flus, bird flu, swine flu that were going on around us, over the past 10-15 years. And so COVID-19 and its various variants are just one among many types of coronavirus. This algorithm was able to identify all of them from samples, and tell them apart from each other. So that's cool. but the researchers behind this project didn't really have COVID or viruses in mind when they're doing it. They were looking more at bacteria. Bacterial infections cause a whole lot of suffering. I know I had one 4 years ago. It knocked me out for the best part of a month, and I had to go on an antibiotics course for a while. But that was a fairly minor one. I've had, and that was in, ear and nose and stuff. It's just not pleasant, but, and they can cause colds and things like that as well. But some of them, if you get, and this is more in other parts of the world than in the West, but it can happen here as well. If you get bacterial infections in certain places, in wounds and things like that, they can lead to sepsis. The wound can go septic, and that can be life-threatening. So,
and it occurs to me, we recently covered the bacteria in pregnant women and in young babies that can kill them as well. And that's a bacterial infection.
Yeah.
Also. So.
Yeah, and then when I was talking about the coating on the medical devices as well, like these things can happen in all sorts of places. And so that was actually really the focus of the research here. And Zachary Dixon, the lead author of this study from the Department of Biology at McMaster, I'll read out a little quote from him that said, there are thousands of bacterial pathogens that and being able to thousands of bacterial pathogens and being able to determine which one is present in a patient's blood sample could lead to the correct treatment faster when time is very important, because you need the right treatment to match with whatever the actual thing is. The probe, of course, makes identification much faster, meaning we could potentially save people who might otherwise die. It's just taking out another cause of death. And it's in the time of COVID going on, and we've talked a bit about heart disease and cancer and things like that on this show, but other high causes of death are often overlooked, and especially with something like bacterial infections, where you're actually looking at a whole range of different diseases that collectively constitute bacterial infections. So it's worth remembering that that's actually quite a big killer or detractor of life quality when you sort of look at it en masse. And this is a technology that will hopefully bring that down a lot and get people treated for these things a lot quicker and a lot more effectively.
Yeah, which is fantastic. We absolutely love that.
Yeah.
So last thing that I wanted to give a shout out today is the concept of wooden floors that generate electricity when you walk on them. I'll explain that a little bit, but that's basically what it is. That's the invention here. So the scale of this, with a sample about the size of a standard piece of paper in the US or the UK, a normal adult person walking on it produces enough electricity to turn on an LED light bulb or a small electronic device or something like that. So this works by what's called the triboelectric effect, which is that when materials come into contact with each other, they transfer electrons from one to the other. But some materials tend to give away electrons, and some materials tend to take electrons, and some do neither. So wood doesn't like to give or take electrons. It's what's called triboneutral.
Yeah, I mean, it doesn't strike you as something that conducts electricity.
Well, no, it doesn't really. It just burns. So, but what these researchers did, and these researchers at a public university called ETH Zurich, led by Guido Panzarasa, excuse me, and what they've done is they took one sheet of wood and infused it with silicon, and the other one and infused it with nanocrystals, and put electrodes in both of them, and this made the wood 80 times better at creating that. It's a similar, creating electricity in that way. Sorry. And so the applications of this, I think, are fairly obvious. If you put these in your home or business and normal people walk on them, then you get electricity in your home or business. You don't have to purchase it from elsewhere. Obviously, it doesn't give off any emissions in that process. And so the next step is to just actually make it easier to make and use some cheaper materials. We were talking earlier in this episode about how technology has to kind of develop to be better and better, but also cheaper and cheaper.
Yeah. Like on that point, if you're going to put it in your home or business, it has to be more cost effective to purchase this thing and install it than it's going to be over X number of years to keep buying power from the grid. This is the thing, like a lot of people in this country put solar cells on their houses, but there's government schemes making that cheaper artificially than it actually would be, and I'm not sure to what extent it actually makes economic sense to do that. It does often make economic sense sometimes if you're in a more remote location to have a diesel generator or a little wind turbine or something on your house to generate power. But I think the more that people can easily generate their own power cheaper than supplying it through a centralized grid, then that's actually quite a good thing. But
absolutely.
But it's the economics depends on how the cost of installation is.
So Panzarasa was very focused on the idea that, this was a proof of concept. He wanted to be able to do it, but it also has to be applicable to the real world. And for it to be applicable to the real world, it has to make economic sense. It has to be cost effective. Otherwise, there's no point. And you can't expect people to be spending extra money for no reason. So I think that's all we have for today.
Awesome. Yes. So just to sum up quickly, I started us off by talking about Star Trek, as I always do, as my friends will know. No, talking about tactile holograms, and then you went on to how extremophile microorganisms can help us defeat aging.
Yes, and in the honorable mentions, you talked about the first all-civilian orbital spaceflight, Inspiration 4, and then I talked about Orca, the carbon dioxide remover, and then you went on to talk about a new algorithm to help detect pathogens, and I finished this up with floors that generate electricity when you walk on them. Thank you so much for joining us for Innovation Celebration. We'll see you guys next time.
Thank you.